After this, there is no turning back.
You take the blue pill, the story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. All I'm offering is the truth, nothing more.
This is a very important video because Blender Geometry Node forever going to change. If you use Geometry Node for a while, you might hear somebody say Geometry Node is good but didn't have feedback loop or for loop is about to change. Now I'm in object mode, just dragging something, play a timeline, and I start to drag something. In real time, curve is just appearing, and if I drag faster, the curve just work like this, and even I stop the timeline, when I drag, everything's updating and it's feedback by itself. So we are going to talk about how to use feedback loop in Geometry Node. I'm using a Blender 3.4 alpha, but I think the earlier version also can do this, but works a little bit different. So if you want to try, maybe use same as mine. And this concept, I learned it from a very genius Bilibili content creator. And if you're on Bilibili, I suggest you must go subscribe their channel because they are like the top of mind on the Blender Geometry Node. And in the future, something might change, but I think the concept still here. So it's very important concept, procedural art or generative art. So it's best you learn it now. And I think Blender can reach Houdini's level. And so the future I will do some Houdini's inspired art and I will share in this channel. So consider to subscribe and hit the like button, and the like button have the new animation, so you want to try that. So as always, I will put this file on my Patreon and you can download that. So now let's talk about how to set up this feedback loop. Okay, so now let's make our first feedback loop in Blender Geometry Node. First, we need to create two objects, just any kind of geometry mesh, and let's call the first one to be loop and the second one to be master. Let's go to the first one and create a geometry node. So this one is loop. Let's create and call it loop. And let's go to the second one and create a geometry node and call it to be master. Now we give another workspace that will be more clear and pin this. So the first one should be loop. Okay, so now it's loop and pin this. So now we have this loop and the master, and we drag this loop to the master geometry node and set it to be relative and just plug this into the output, and also go to the master one and we drag here and to the loop geometry node. Okay, and set it to be relative and plug this to there. We just give the master to the loop and the loop back to the master. So now these two is actually like a loop. We only need to worry about this master. The loop, it just works as like a container. It doesn't need to be work anymore. So we can hide that, can join the area. Now we work on this master. So now we use a join geometry over here and we create a cube, and now we plug this cube into the join geometry, but make sure you plug this not on the bottom of this, on top of this. And this is very important, make sure your data order is right. And now you will see your cube, and let's try to make some change of that. So make a transfer, and now let's try to drag this cube to see what happened. Become like this. It's very unusual. And let's see in the wireframe. So you will see something like this, and maybe we can make it the cube smaller. Now if we try to drag this, you might already see this is kind of like a feedback loop. The loop is working. Let's set this to be 0 first, and we want to clean this result because this result is not perfect. So let's try to clean this. The easiest way, just plug this off and plug this back, it will clean. But this is not the proper way because we don't want to plug this in and out all the time. So let's use a switch, just plug this in. So now whenever we make a different, we can click here to clean that and just make something and clean this. But there's another way we can improve this. Use at the same time, and we use this frame with a compare and set this to be equal and plug this to A and set this to 0. And we just plug this to the switch. Now whenever it's frame 0, it will clean everything. So when we do anything change here, we just set it to be 0 and it's clean. And whenever we want to make some change, just go to the frame whatever or frame 1 and just make your change. So now if we do some animation, for example, maybe we use this frame to drive, and when we go to 0, it's empty, but when we hit play, you see it's keep growing by this frame number for the transformation. Now we have this animation and we can go back to frame 0 empty, and whenever we play, it's start all over again. Okay, now we can frame this for the player. So now let's take a look at this. So this is like a clean setup for anything we will do later. So what is this means? Let's use this as an example. Think this block is a piece of information, piece of data that being generated to here. So if now we are like in frame 1, it create this data to here and all the way to output. It goes to loop over here. And now we are at frame 2. At frame 2 here, create a new data. And the one from the loop will go all the way to here. And it come to here, right? Over here, they join together. They become like one data, like this. And now it passed down here to the loop. So which is become over here. Keyframe 3 generate a new data to here, and the loop come back to here. So these two information will be lower and the new data is on top, which is index 0. And for the join geometry, they join together and it passed down. It's become like a loop. That's why I say this kind of bottle is the idea of our container for the data. Whatever is being put new is on top, and if there's one more new piece of information, it will push the previous new data down and the newest will be on top. Just think about this kind of things as your data container. So let's see in the spreadsheet. So now the spreadsheet is very important. So we will take a look at this later. Now you get this idea. The new data go here to be index 0 and pass down. So now this is like 0, 1, 2, 3. So all these are just a visualization as an example of how the data will be ordered. So now let's examine the real data from the spreadsheet. Index 0 to 7 are vertex for this cube. I'm not sure the order, but maybe 0, 1, 2, 3, 4, 5, 6, 7, which is 8. Whenever I make a change or I change the keyframe, the data will be updated like 8 more index because 8 more point. All the data will be pushed down here. Cube is a little bit difficult to keep tracking the data, so let's switch to a point. So now let's use this point, and now let's reset this. You just press your arrow, the 0, and go back to 1. So now we can see a new data. So we have to switch this to the point. So now we can see, so let's reset this point. It's at 0, 0, 0, right? So that's make it like a offset. So now the new data, you can see index 0 will be 0.1 and 0, 0, exactly the same as this. So when I keep pushing, you will see the newest data will be on top because this is on top. So I hope you understand this. This is quite important, that it's all the data being stored, and this is how it looks. It's from the oldest one, and this is the newest one. In the example you see, we will use all this point to draw curve, and from that we make it to be like a tube. Let's see how we're going to do this. So now we will make a sphere, and we can make it smaller. Okay, so let's bring this sphere into the geometry node and set it to be relative, and just put the location to the translation. And let's try to drag this sphere when you're on this sphere and press G. Now it doesn't show because I set it to 0. So make sure you are not in the key 0 because key 0 is for player. Let's go to the key 1, start to drag this. So now we see some point appear with the sphere location. So let's try to reset all this and maybe also set this to be 0. So now we try to play this timeline. In the same time, we can drag this. So now you see when the time passes to the limit of your keyframe, it will refresh. So you just set the end of your timeline to be like very large, so it will not reset so easily. Okay, so now we can have we can draw something, even the location is not changed, it's still updating. Just keep in mind. But if you're not playing the timeline, you can still draw. Now we can draw infinite number of the point. But actually that is not what we want because it's too much. We want to set it a limit. Can set the limit very high, but we still want some limit. So now we can give us some limit over here using delete geometry and just put it here and set this to be point. There's a selection. So let's say use a compare. To set it to be greater than 10. Everything is greater than 10 will be delete. So only remain the point is less than 10. So let's try to grab this. We will only have 10 point. That is how we set the limit of this. The spreadsheet now it's showing not what we want, because what we want is to see all these points, the location of this point, but now it's showing this sphere because now we are grabbing this sphere. So now we can use viewer node and drag from here. We can drag this result over here and turn on this eyes. The newest version is a little bit different, 3.4, so it's a little bit different. It's much better. So now we turn on this and we can examine on this. So now let's try to grab this sphere. You will see your value is updating from 0 to 10. That will be 11. We can set it to greater than or equal, so that will be exactly 10. Now we got this. So that is the one more function that will be important as well. So we can run this and we can name this data size. So now you can use this number to set how long you want your curve to be. So maybe 30. Now the data will be like 30 points. Okay, so now we got that. And make sure sometimes you just want to turn off this, or you will be sometimes confused because you forgot that it's not the final result. So maybe just turn off that for right now. Okay, so now we got this point data. So what we want to do is store this position data for each point to somewhere, and we can use that. So let's use store named attribute. Okay, so just put it here, point position. Okay, so point P for the position. Now the position is vector. Let's use a position and put it here. So now we store this attribute, and we want to use this to somewhere, and where we want to use it is in another geometry node, and we can capture this attribute and draw some curve. So let's make another geometry node is to be show curve. So we name this as show curve and make a geometry node and just name it show curve. And let's drag another workspace because we will work between these two a lot. So that's we can use two space and we can pin this show curve. Okay, so now we will like to use this attribute. So let's try to call that named attribute. So if we just try to find this attribute on the other geometry node, we will not find it over here. That's because we need to drag this into our current geometry node. We can set this to relative, and now we can try to find it again, but we still will not see. That's because it's not being plugged to anywhere. So you have to be plugged to somewhere to activate. You can find this attribute from here. So that's something you have to keep in mind, but that is not how we want to plug. So do something differently. We know we will want it to use this point to draw some curve. So use a curve line, plug it to here. So now we got this curve, and we want to use this curve somehow map to this point. We have to resample this. So this count number will depend on how many points we have. And then we just use that to set position. That's how we use this curve to map here. And now we want to find the data over here. So first we need to know how many count we need. So now we use a domain size. So let's drag this to here. And first we set it to be point cloud because what we have here is point. And we can plug to here. Now we can try to use the viewer to see what is the output for this. So the output is 30, so which is means we have 30 count. But however, I will set it to be mesh, and then we use a point to vertex. That's because vector is easier to carry some data than the point. Some data will not be stored in the point. Better you set it to be vertex, and make sure here also set to the vertex. And let's try to refresh this and go to key 1 and try to drag this. And now we see 30 vertex. Okay, so that's right. So that's 30 and 30. Okay, let's turn off this. So now we use a sample index, and this is a new node for 3.4. It's a replacement for transfer attribute node. So the 3.4, the transfer attribute node is being reworked to the several different nodes. So now it's called sample index. Now we need an index and plug this over here and just set this to be vertex. And now because this is being used, so we can find point position. Yes. So now we can use this and also set this to be vertex and right here. So let's try to the position. So now you see your curve being mapped to here. Okay, now we have curve, make it to be tube. So it's use curve to mesh and use curve circle and set this to be lower, thinner, so we can see. And let's try to drag this. So you see now you can draw some stuff in a real time. And if you set this to be super high, 300, okay, so that will be. So now you see the data will never pass 300. Earlier one will be kept out on your data. So you will never run out of your memory. Print this. And let's try to use transfer, give the translation, maybe some value. Let's try to draw again. So you see as the update, your drawing will be pushed in one direction. So maybe you will like to draw something like this. You can do something very fun, or maybe you wanted some other direction. just change that. Okay, even the size, maybe you can give us some value. This is also kind of interesting. It's like it being expand like a universe. So let's frame this. It's very useful. And name this to be offset. Okay, now we have our base set up for drawing curve in a real time. But what is making this super exciting is we can calculate the speed of how we draw. So now we can give some radius for curve. If we draw faster, it will be thicker. When we draw slower, it will be thinner. So how can we calculate the speed? It seems to be very advanced, but actually it's very simple. We just calculate the distance between 2 points. Okay, so let's imagine our sphere is over here because here is blocking our view. So imagine our sphere is over here. And we want to calculate this point and this point. So this is the previous point and this is the current point. We want to calculate the current point and the previous point, and the distance will be translated to our radius of the curve, and we have to store this information. So this is current point, so this is index 0 and this is index 1. So we always want to find the index 0 and the index 1. So yeah, let's do this. So now I mute this transform first, and I'm trying to get the previous point. Use store name attribute and set it to be point and vector, and I will name that to be CP for current point. And now I'm use sample index. I will sample the index for 0 and set it to be vector and position. Plug this to here and plug this to here. So this will be sample the index 0, which is the newest point, and I can just duplicate this, make it previous point, so call it PP. So just put it here, drag all the way to here, and I can set this to be 1, so it will be the previous point. This is the current point and this will be the previous point. We can try to use this integer, okay, and set this to be 0. So here is 0 and use math, and we add 1. So no matter where I start to sample, this one always will be the previous one, the one that before this one. We can frame these two. Okay, so now we can store these two, and I will try to call it out using named attribute, and this one will be CP and this one will be EP. Okay, so now we have these two, and we want to find the distance between these two, so use vector math and set this to be distance. So we will get this distance, and this distance kind of demonstrate the speed. So again, we can store this, store named attribute, and then this to be speed. So now we have this speed. So now we try to take this speed in this show curve geometry node. So let's use named attribute and set it to be speed, and use a set curve radius to here. So this will set the radius. If we just plug this to here, it doesn't work because this attribute is actually coming from here. So we have to use sample index, just like over here what we do. So we use the index. Okay, and plug this value to here and take the geometry from here and put it over here. So now we have some radius, and let's try to drag this. So now you will see it's constantly changing. If you go faster, the whole thing will go wider when you drag, and if you go slower, it's going to be thinner. So that is not what we want. Actually, what we want is have some variant, like some part is thicker and some part when it's the size being set, it will not change anymore. It's not like this, the whole thing is being constantly changed. So why is that? It's because let's take a look at this value. So let's watch this value. When we drag the value from here, viewer, all the index are exactly the same, which is they all being updated for the latest one at the same time, because this named attribute is updating all the value for the speed inside of this container, update all at once. But what we want is actually only update the latest one. When there is the new one coming, it's only update the latest one and update the latest one and update the latest one and update the latest one. So the older one will be not changed. We will make something called quad. So how can we do that? Let's think about this. So here is update everything, and that is not what we want. We will want to update only the latest one, right? So we can use a separate geometry, and let's put it here. Okay, so we will only update the index 0. So compare, and this to be integer and equal 0. So it will be, here will be index 0 and here will be the rest of them. So we only update the index 0, and the rest of that we can just pass down and use a join geometry, plug them like this. It's also on the top, so it will push down the rest of that. Let's try if that works. I just find out somewhere a little bit weird. Yeah, I should plug this to here. I forgot. So both of these, the current point and the previous point, should be looks pretty much the same, only the index are different. So now I think it should works fine. So if you make the same mistake, just you can fix that. Okay, so now we actually have a speed detector. So here it's actually quite important. This kind of setup, if you're going to make something like this very much and use it in your future project, you can make some random value, but it will be only update for the latest one or something, or color, random color, because if you set some random color for this, you don't want it will be like a keep changing all the time. When it is set from the first point, it will be stay. So this is how you make it like a quad to do that. So now sometimes it's like too slow and it will be stay together. Give a base value to add, maybe add 0.5. Okay, so, and you can do some math about this. Maybe multiply this, multiply 2. That will be it. And now we can try to use different curve. So before, this curve is like a poly curve, so we can use this set spine type. And here before it's like a poly, and if you set this to be something like this, NURBS type, the curve will be much smoother. It looks nicer. It's a little bit slower, but if you don't draw too much, it will not be too heavy. And maybe give some material. So just go to your show curve and make a new material, and you can just set material over here, plug it to the output. Okay, so whatever you like, the color and the roughness. Let's set the HDRI. Okay, so now play a little bit. We can even make it like a rotate, maybe 5. Go to frame 1 and try to show something. So now it's spinning, and if you like, you can just use subdivision smoother. So this sphere is kind of like your brush. In my example, I use something like a pen to do the brush. I can make it like have some direction that demonstrate my movement. And you can think about how to do that. Not that difficult. As long as you have the previous point and the current point, you can find 2 points and you can find the direction. Yeah, so now that's basically it. It looks totally real-time already, and even we play timeline, it will be rotating by itself. In the meantime, you can just draw. So if you want to render this, if you just render, it will not show, it will not be here. If you want to render, you have to apply the master. Click on your master and just hit apply. So now it will be applied. So whatever the data adds to your show curve will be stable. So when we go to the show curve, and we can put the shrink curve over here. Now we can use shrink curve to control the animation, and also when we hit render, it will be there. And also when you save your file and reopen your file, you will still see this image. But actually the best way to render this as animation or even a still image is to record your mouse movement, which is to record the location of this sphere. So you just hit this record, you just play your timeline, and now you drag your sphere to whatever you like. And now you stop your recording. So your record will be here. Go back to frame 0 and you just play your timeline, and it will be draw out like that. And you can do some change about this keyframe. Grab this keyframe, frame close to the 0, and we can just hit the render. So now you have your real time being recorded and rendered out, and it's pretty smooth. The result is what we expect. It didn't have any glitch or what, so it's very useful ways to do your render. It's not like a experimental glitch stuff. So that's how you do your render for your feedback loop. So that is the feedback loop function. It have endless potential. I hope you guys get the idea. Try to do something even more advanced than this. Enjoying your experiment and enjoying Blender. This project file, which is the full one in the opening animation, will be in my Patreon. And try to hit the like button. There's new animation for the like button. And see you next time. Bye bye.